Good morning, everyone. My name is Rachel, and I'm with the marketing team here at Compunnel Digital. And I'd like to thank you for joining us today for our webinar on how to transform business data into an enterprise asset. Before we get started, just a few housekeeping things. If you have questions, please enter them in the GoToWebinar portal and we will answer them at the end of the webinar. And once the webinar replay is uploaded, you will receive an email. So if you need to drop out halfway, we will send you the replay. Again, questions go in the questions portal on GoToWebinar, and I will go ahead and introduce our speaker here today. Pradeep, can you please move to the next slide? Thank you. All right, our speaker this morning is Pradeep Sivanadri. He is our senior data scientist here at Compunnel Digital. He has over 15 years of experience in software engineering, including data science, big data, machine learning, cloud computing, automation, continuous integration. He really has worked across all industries and built solutions for e-commerce, hospitality, security, search engines, and more. As our lead data scientist here at Compunnel Digital, he has led the development on countless applications, including our recently released Unlock OKR program, which helps organizations focus their time and attention on what truly drives business performance with OKRs. So Pradeep is truly an asset here and will have some valuable information to share with you this morning. On the agenda today, Pradeep will be sharing how to turn your business data into an enterprise asset, how to really extract intelligence to enhance your business decisions or feed that back into your applications and decision making or monetize it. So without any further ado, I will hand things over to Pradeep.
Okay, thanks Rachel for the wonderful introduction. And yeah, coming to our agenda. Hello everyone. Today we have the following points for this meeting we wanted to cover. So we start with the understanding part of data and then enterprise, and how does the enterprise data is relevant and how can we make best usage of that using different techniques and what are the different processes, methodologies, etc. And so why actually the businesses are trying to go digital, right? So what are the key drivers which are the factors for the business go digital, and then how can we better leverage the existing technologies, right? And then we also discuss about the business value, what we get out of this entire process, and how can the businesses get benefited. Then also we talk about some of the characteristics of the business data. What is business data? What are the different types of business data we have? And what are the important characteristics, and how to better manage, leverage that. And we also see the different dimensions of that, the same thing, and how different people will look at data in different various ways, depending on their role and use case. And then we talk about the dimensions. So this is an important aspect in terms of data quality, because even though we have tons and tons of data in the organizations, and if that data quality is not good, then it's almost having not having data, right? So data quality is important, and we'll also see what are the different dimensions which talks about data quality. And then we'll also talk about limitations, right? What are some of the limitations of data? Then we also have the GQM framework that we'll see in detail, then a data management model, then DIKW model. These are the famous models which people use in the data space, then how the business can get benefited. So at last, we'll talk about data mining. So what are the different models in data mining, and how we can use different algorithms and try to get insights, or try to predict, or try to do any kind of business problem into a data mining problem, and then how we can convert that and utilize in the business. So yeah, that's all the agenda for today. Then moving ahead. So first we'll talk about understanding the data, right? So as we talk about data, data is now talked in every industry, every business, in every organization. So some of the key understandings, right? So why we need data? So data is required to capture and store the business requirements in terms of different parameters, different elements. So businesses are having different entities, right? Events. So everything is captured in terms of data, though it might be stored in relational databases or different mainframes or ERP systems or cloud, so wherever they're storing. But end of the day, business want to capture their business events and business categories, all the business information in terms of data. So it is coming with different formats based on the industry and based on the application which we are working with. And so it all depends on whether we are using how the applications are connected together, right? And all these things. So data will be coming in different formats for different industries and businesses. And so what quantifies data is it should be repetitive, right? And so it should also be reproducible so that whatever we are trying to analyze the data, so that should make sense. And whenever we want to reproduce it, so the data should be reproducible so that we can get insights and help the business teams to take their decisions. And so always the data is encoded. So most of the times using some standard formats or custom format, depending on the client or geography or the particular project requirement. But most of the times data is always encoded. And coming to the business value, so definitely data as such will not give any value, right? Because data is just in a raw format. Whenever we try to extract some meaningful information out of it, then it really gives some value to the consumers or the customers. So we talk about what are the different techniques which help us in bringing information out of the data. Then data also has its own journey or the value chain, right? Which talks about the journey from the raw data to the information and then to the knowledge. So we'll see all these details in the coming slides. And then coming to the data representation. So always it's better to encapsulate and then use it for further analysis and processing. So definitely data is gathered and then it is in unorganized format as we discussed, so which can represent conditions or categories or business objects. So then we just talk about data. Now we'll see about the enterprise. So if you see this particular diagram here, so we start with the bottom business function. And then if we go up in the ladder, then we have a line of business and then a company and then enterprise. So how this particular diagram is in context with this current discussion is, so data can be at all the levels, at all the different functions. But now when we talk about an enterprise, so enterprise is actually a broad aggregation of the companies, right? So group of companies, which is a sector level. Then drilling down, enterprise will have multiple companies, which are focused on different products or different services, only focused on the particular entities. Then companies will also have sub-entities like line of business, which just focus on to carry out a particular business function. Then the business functions are real kind of work units where the mission is accomplished. So if you see example in the BFSI domain, so what talks about enterprise is the vertical itself or the sector. Then the companies, we can talk about banking and the insurance. These all falls under BFSI sector, but their particular product or the service is different. So based on their use case, so we can try to categorize them as different companies. Then the line of business, right? So what really banking is doing, banking might have multiple functions. So credit card is one of them. So credit card can be talked as a line of business. And under credit card, so again, there are multiple business functions. So one of them might be risk management. Similarly, the insurance, when we talk about insurance, there are multiple line of business like life insurance. And the life insurance might have business function like marketing. So why we are talking all this in terms of data? Because so data we should manage at the enterprise level, right? So whenever we manage data at enterprise level, that really helps us to minimize most of the risks nowadays enterprises are facing, because enterprises nowadays, they change their operations because of many factors, right? So increased globalization and because of some the laws and regulations and increased internet, increased mobile apps. So because of all these things, nowadays business functions really got changed. And so because of all these opportunities, so at the same time the risks also increased. So in order to minimize the risks, so it is recommended to maintain the data at the enterprise level rather than maintaining data at all the levels in different formats and different entities. So whenever we talk about maintaining data, so if you can see on the left-hand side, so the granularity is from top to down, and the abstraction or aggregation is from bottom to up. So if we maintain data in this format, it will definitely help enterprises in minimizing their risks in various different ways, right? And not only minimizing the risk, but it also improves the visibility. So if a company wants to see what's happening across all the line of businesses, they can still see that because the data is aggregated and shown at the company level from all the underlying line of businesses. So the visibility is there, and the reduction of the risks are there, and data management will be smoother if we manage data at enterprise level. And yeah, abstraction, we can definitely do it, abstraction of data and hiding whatever the irrelevant information and only showing the information which is relevant to the line of business and the company at enterprise. So that's why yeah, we are talking about these different entities in a business and how they're related, and what types of data is there and how it should be managed. So coming to the drivers, right? So what is driving the business transformation? So first of all, yeah, new technologies, definitely. That's a key factor because nowadays computing and storage is, it's like very much improved compared to last few decades. So cloud is really taken up a massive growth, and then people are really using cloud platforms to compute and store. Then increased competition, definitely. It is also one of the key factor where businesses want to go digital and then utilize their existing data and then see how they can extract insights so that the better decisions can be taken. And the other key factor is we have social media and mobile apps. So everyone or the key industries really want to utilize their brand presence or improve their marketing, reach out to customers or help the customer service. So all the different functions are definitely utilizing the social media and mobile apps. So that is also giving us most of unstructured data, right, to deal with. And definitely the data is coming with a huge volume, variety, and velocities. So, and the other one is coming to different data models. When we talk about the systems nowadays, right, so they are all kind of systems which are collaborating much and interacting with multiple systems for different things, where there is data coming from multiple systems, and if we want to analyze them and then build and try to extract something, so we need to build a data model which is common across all these things. And pace of change, yeah, that's also other factor where globalization and new economies and technology. So these are other key factors which are driving the business transformation. And also the need for operational transparency. So most of the regulations and then most of the regions, governments are regulating the businesses to be as transparent as possible so that the customers can get information whatever they're looking. Then we talk about the data and business value. So when we talk about business value, so these are the three main fundamental things which gets because of the data, right? So the first one is what we're talking about is decision making, right? So definitely the data helps us in decision making when we analyze them correctly and recommend them and take correct decisions. So that's a very fundamental use case for data. And we can also not only decision making, and we can also try to match the compliance and regulations as per their organizational requirements. So we definitely need to have the standards in place. So some of the formats or some of the particular compliance restrictions as per different countries. Right? So different countries having different regulation rules based on their industry or based on their location, they're operating the particular business. So they need to adhere to all these particular rules and regulations. So data also helps in adhering to the compliance. And then customer service, if whenever we want to serve the customers effectively, definitely we need to understand, right? So what the customer is having and what kind of issues they are facing, and so on and so forth. So data will always help us in all these three key areas. And whenever we talk about data, so it should also be at the heart of our decision making. So we should never, I think the data will come at a later stage and then we can try to see what is there in data. So whenever there is a strategic meetings or strategic kind of decisions, so data should be at the heart of that. And coming to the decision making questions, which we talk here, so definitely they are not so easy to answer, right? So when we talk about the level of performance or the affecting factors, so none of them are easy to answer, and no individual can try to provide the answer for them. But if we take help of data, then yeah, data will provide the necessary support so that the business teams or the management teams can take the decisions. So definitely data is playing a big role here. And so now we talk about the business data, right? So we have seen what is data, we have seen how it is useful, and we have seen what is the enterprise. So now we are talking about different types of business data. So when we talk about any business, so fundamentally we talk about four different types of data, like reference data, master data, transactional data, and metadata. So all these four different types of business data are kind of critical for any businesses. So we talk about transactional data much because reference data and master data are not increasingly growing so huge. So transactional data is very important, and similarly the metadata. So metadata, which also has different types of metadata available, like which talks about the business or which talks about the technicalities. So we need to yeah, understand all different types of business data which are there in the business. And so if we talk about the characteristics, right? So definitely anyone is capturing data, then there will be some purpose. So definitely we need to understand why the data is captured, right? And what is it present in it and how to interpret that. And once we understand the data, then we can try to use that insights and derive some of the meaningful observations and understand the data trends and use them in a particular business decisions. And coming to relevancy, so we talked about relevancy of the data here because the relevancy of data will only increase when it is shared across enterprise. As we have seen, enterprises are having multiple line of businesses and multiple business functions. So if the data is not shared across, definitely the leverage of the enterprise data we can't achieve. So the data should always be shared across the enterprise, given the rules and restrictions of the particular organization. But yeah, only when data is shared, we can take best advantage of that. And so lastly, we talk about business data. That is an irreplaceable asset to any organization because if you see how companies have transformed, so most of the companies are data driven and purely data companies, right? So, or even the traditional businesses which have massive data, so they are definitely having an edge compared to their competition. So definitely business data is a irreplaceable asset, and better leveraging and utilizing and taking advantage of that will help us in better monetizing it. And as we have seen, so this is the business data which we have seen under four different entities. But when we talk about the business data to different persons, so they might have a different perspective of it because they see data based on their role or they see data based on their particular line of business, right? So if you see, right, so the data classification, we can classify the business data into all these elements. Whenever we are seeing the data, why it is captured, right? So what is the purpose? And we have seen already that why the data is helpful in an organization, like providing decisions or compliance or customer service. So what is the purpose of data capture in the organization? And coming to origination, so from where the data is coming, right? Is it coming from the social media or external applications, whether it's structured data, unstructured data? So we can try to classify and try to put that in different buckets for any business enterprise. And then coming to the processing part, yeah, so there are many different steps which involves in data processing, like whenever we get data into an enterprise warehouses, or when we talk about big businesses, we do a lot of conversions as per the business rules, and we migrate data from one system to other system, and we validate the data whether it's correct or not. We sort it, aggregate it, and then analyze it. So definitely there are a lot of steps in the processing part, and the persons who are dealing with each process, they will try to see that data in that perspective. Coming to the analysis part, so we have different types of analysis which we can perform, like qualitative analysis or quantitative analysis based on the type of data we are dealing with. If you're dealing with numbers, definitely the quantitative analysis is recommended, and then we can try to get some of the numbers out in the reports, and we can present that. And if you're talking about unstructured data or textual data, we can do a qualitative analysis. And coming to time, so we talk about validity, like here, like, so what is the time the data is there, and what type of decisions we want to take, whether we are talking about historical data, or whether we are talking about the current data, or whether we are talking about the future. So based on the different time zone or the different validity, we can do a different type of analysis on this data. And sensitivity talks about the permissions or how the data is accessible over the organization. So each organization might be having different rules. So whether data is restricted, or it's a confidential, or it's publicly accessible data. Then similarly, we also define ownership. So data ownership lies with the enterprise or a business function or a LOB. Then what treatment we are doing, whether we are keeping this as a source of truth or systems of record or systems of innovation. So there are multiple different treatments which we can try to apply based on the data element and how frequent it is changing, whether we want the data to be changed slowly, or it's not changing so quickly. So we can try to keep data systems of record. And if we are working on ad hoc projects, so the data is having a shorter life cycle, where we'll try to keep systems of innovation, which which might even last less than a year. And coming to the security, so we talked about all the roles and responsibilities, but we can also talk about whether the data is in rest or data is in motion, whether data is moving continuously or it's not being used currently. Right? So we can categorize based on all these factors. So all the businesses will try to have all these different elements based on the data captured across the different units, and it's always recommended to have this kind of classification. Then, as we discussed initially, so when we talk about data quality, so there are there are multiple many more qualities towards data, but I try to list down here top or important qualities when we talk about enterprise data quality. So completeness, each business has its own definition to take data as whether it's a complete or not. But the best practice is we need to strike a balance between how much effort it is required to capture this data and store versus not having the data in the system, right? Because everything is time and effort. So we need to really understand the usage and the requirement of the data, whether it's really required for our application or not. And consistency, it definitely talks about the data traceability and having the value consistency. And conformity, right? So we need to adhere to specifications as we discussed, so guidelines. data attributes, everything we need to be confirmed in the business. And so cardinality talks about uniqueness, right? So when we talk about uniqueness in data, so like when we are talking about the primary keys, so data is all unique, right? And so we might have data quality issues if we don't have these kind of cardinalities, and especially lay out the rules for different cardinalities based on the type of data. And accuracy talks about so how truly we are reflecting to the real data, whatever we are capturing. And data correctness. So correctness talks about what is the data value accepted, and what is the freedom of error which we have, right? So there is a slight difference between accuracy and correctness. So accuracy can be anything, right? So like I can be 60% accurate, or I can be 90% accurate, or I can be 100% accurate. But correctness is not like that. Correctness is whether you're correct or not. So it's a kind of binary, right? And so we can't have um, when we talk about a phone number, or when we talk about a customer ID, I can't have 98% accurate customer ID. I need to be 100% correct, right? So we need to see that what is that particular field we are talking about, and what is the quality which we can apply on the particular field. And accessibility, definitely accessibility is very much required. If we can't access data, it's almost not having it. So we should be able to search it, retrieve it, use it, and whether we want to access it randomly, we should be do it. Sequentially, we want to do it, we should be able to do it. And yeah, timeliness. So when we talk about what is the most current data, right? So we should, whenever the application is requiring the most current data, so it should be readily available. It's not that the data is not available now, but I'll get data after 5 seconds. So that might not be suitable for some of the applications which are working on real-time predictive applications. So timeliness is also important quality, and redundancy for backup and recovery. And when we talk about the coverage, and so that is actually data sharing, as we discussed in the last slide as well. So how the data is shared across different business functions or organization, and the enterprise level, how data is covered. Integrity talks about the data should be unaltered, or we should be able to trace back to the source, and then we should be also able to connect to other data. So whenever we are talking about extracting information, so data should be having all these qualities. So only then, yeah, whatever we are doing, it will be really helpful. Then we see some of the limitations which we discussed. So like significant amount of data, right? So normally enterprises are collecting significant amount of data, but data comes with always some kind of bias in it. So yeah, how to eliminate that? Then that's all a different story. We need to work with the teams who collected this data, and on what basis they're collecting. And so these are all the different limitations which comes with data. And before developing any predictive models or any algorithms, so we should first see, right? So what are the existing limitations? Only then, yeah, we can proceed. Otherwise, if we are just simply proceeding with the data and then applying some of the existing algorithms or building new algorithms, definitely that might not give a best results which businesses can really use them in taking decisions. So understanding the limitations is very, very important. And then we talk about data, right? So data doesn't always translate insights, because when data is telling something and business is not accepting that, right, and they're not acting upon that, so definitely it's a kind of limitation, because both the teams are not in sync, and business teams are not really agreeing to what data is saying because of XYZ reasons. But yeah, so this is one of the limitations. And when we talk about data quality, in the previous slide, we have seen what are the different elements of data quality. So even if we have the quality data available, but that might be relevant for today, right? Because maybe after 6 months or after 1 year, there might be a different business need or different regulation coming up at the particular business location. So definitely that's also one of the limitation, and then it might not work out very well. So we need to understand all these elements. And the other important one is data management. When we speak about data management as such, so it is a quite expensive and time consuming as well, because we need to do all this processing on data, and everything is it should be time and resources. So business should be ready for data management. And data has low relevance for the first time events, right? So because most of the predictive models or any of the algorithms will only work with the historical data. So if we don't have historical data, definitely none of the algorithms might give good metrics. So definitely then we need to take help from business teams or some simulation models or some other models. And at last, we also talk about data will definitely try to mislead when the people are trying to create the graphs based on different KPIs or different level of granularity, or how they're creating the graph. So one should be very careful how the data is shown to the management team. So quickly, I want to discuss about this goal question metric framework. This is the GQM framework, which is recommended and used by most of the organizations in order to overcome some of the limitations which we discussed, and how to get a better data management in the company. So definitely the goal driven, right? So any project, like any IT project, so the data project should also be having a goal and with defined measurements and how to measure, and it should be context sensitive. Without context, it is irrelevant. And whenever we are doing, it should be a top-down approach. Like we should try to refine all the goals and try to ask questions, create questions, and try to prepare some measures. So the process should be top-down, and document everything, like what we are measuring and what refinements we are doing, right? And then once we do documentation, then the bottom up will try to ensure that whatever the data we are collected, whether it is correct format, and are we interpreting the collected data, and are we able to achieve the questions, or are we able to achieve the measures what we have listed out in the previous phases. So the bottom up will help us in validating the data collection part. And people oriented, definitely, because if people are not involved in all the phases, definitely there will be gaps, and it's always recommended to actively involve all the stakeholders in the entire process. And sustained, definitely, because it should be a continuous improvement process. It's not a single phase, or it's not in one pass. So definitely it's a continuous process and continuous improvement, and reuse the knowledge gain, and we can try to leverage whatever the mistakes or whatever the learnings we have in the previous projects. So this is the framework which is recommended for the data projects in order to get maximum benefits or try to extract more from any of the underlying data. And expanding on the previous one, so it talks about multiple steps, like the stakeholder analysis, and then try to formulate the goals, right, and identify the parameters, and translate that into quantifiable questions. And some of the questions we can answer, and some of the questions we can't answer. So for the questions we can't answer, try to derive a hypothesis around that, and try to do a null hypothesis versus an alternate hypothesis, and then see what we are trying to prove here based on some of the other elements, and keep that ready. Then derive the attributes, definitely that's required. And metrics, once we have attributes for data elements, so then we can try to derive the metrics out of that. And once we have that, we can try to apply the reverse framework, and then see, as we have seen in the last slide as well, whether these metrics are having enough information to answer the questions, whatever we have in the initial phase. Right. So once we apply that and validate the process, so the next part is to derive the data elements from the metrics, and then finally build a data model. And this is the other framework which we have discussed initially. So this is DIKW framework, like how to move from data to the wisdom, right? So it talks about multiple phases here. When we are in the data phase, so we are just collecting the data in terms of some different systems or different, whether it's a manual process or data collected through some other systems or the business systems. So data is collected in terms of multiple parts. So still we are in the observing phase. Right? So that talks about the data part. But when we try to build the relationships out of the data, and then that's where we are trying to extract the information. And that also talks about the descriptive analytics or descriptive kind of data processing part, where we are trying to extract some information based on the underlying raw data and trying to apply some rules and regulations and some business relations on top of that and extracting information. So all these things is a history, right? It's all past events, because that's not which is going to happen tomorrow. But when we have the information, so based on the information what we have, we can try to predict the future. So that's where we how we can predict the future. So if we want to predict the future, we want to understand the patterns, right? How the data is structured, how the data is related, what are the different elements which are having significance or insignificance, how the elements are correlated. So different techniques will come here, and different algorithms will try to apply and then predict the future. And that's where we talk, or we call as knowledge. So when we know what is going to happen in the next 3 months for my business, so I have the knowledge, right, about my business. So this is where most of the data mining algorithms, or most of the data mining and machine learning techniques will come and fit, where we talk about the predictive part. And the next one is the prescriptive. So prescriptive is it's more kind of wisdom, right? So where uh, it's not that we are not predicting anything, but we want to know where we want to go, and then we are asking the system, show me a path, right? So I want to reach this target, and based on my past performance, based on so many XYZ factors and external situations, so how soon I can achieve, or what should I do if I want to go there? So that's where the wisdom of a business, where the prescriptive analytics and again most of the machine learning techniques and predictive algorithms will come and play here. So these two parts are the future events, and the first two were talking about the past events for any data. And so this is also popular modeling, right? So which talks about cross-industry standard process, the CRISP data mining model, and which has 6 phases in it, and right from the business understanding, and again everything is it's not one pass, it's all continuous. So this cycle will go on in multiple phases. So starting from business understanding till the model deployments. So we'll discuss each of them in detail. So when we talk about business understanding, so we know, right? So how to convert a business problem, because no one in the business will come and tell me, go and run this random forest on this data set, right? Because business want a solution for a business. They don't want a technical, or they won't recommend any technical approach. So one should be able to understanding the business in order to convert that into data science problem. We should be having thorough knowledge on the business. Then once we have knowledge, so we should be able to decompose the problems into the relevant data mining tasks. Right? Only when we able to decompose, then only we can build a solution for a smaller task. Right? And the next part is data understanding. So we have discussed so much about data till now. We should be understanding the strengths and limitations of data, and how the data is collected in this organization, or why it is collected, right? On what purpose the data is collected. If we are repurposing the data, if we are using the already existing data, we should understand why the data is collected. Only then we can see whether we can use that or not in our current solution. And we also talked about cost and benefit. We can't go and gather all the data in the world. So we should see what is relevant and how much cost I bear and what is the benefit I get. And preparation part, yeah, definitely there are multiple different techniques and multiple algorithms which are required in order to prepare, because when we talk about numerical values, there are some techniques like normalizing or scaling them using different techniques, so that whatever the algorithm we are using, it can try to understand it correctly, and converting or try to impute the missing values, or try to fix some of the data quality issues, right? Try to convert into different formats. So all this comes under data preparation. So one important point here is we should understand there is a concept called leakage, right? So leakage is definitely we should be able to discuss, because see, mostly what happens is whenever we talk about any business problem and data mining or data science problem, we go and try to apply algorithm on the historical data. But we should really understand whether this historical data, whatever we are working on, whether that can be available in the real time, right? We have data in the history, but when we apply this, when we run this algorithm in the real time, can we have the data before running our model, or will that data be available only after some time, right? So that is a really important aspect which everyone should be focusing on, so that we really run good models and try to have good predictions. Then the modeling is really that's a critical phase where we try to simplify or try to represent or generalize the data using some of the modeling algorithms or custom-made algorithms. Then we can try to use them to try to predict in the future or try to understand the parameters. In the evaluation phase, so all data mining algorithms definitely will try to evaluate, and then before deploying into production, it should pass some of the tests, and then but even if they pass some of the test, that model might fail in the production, because we might not consider some of the external factors while developing these models or try to develop the solution. So that's why I mentioned it's a cyclic process, and if the model is not correct, or if we are trying to get any issues or errors, so it will be corrected in the next pass or next phase. Coming to deployment, yeah, definitely we should consider the model deployment for a greater speed and compatibility. I'm sorry, compared to the development environment. And so it's also recommended to deploy the entire data mining system into production rather than only deploying the model. So that's a best practice to follow. And these are some of the terminologies which we can quickly look into, like how to think data analytically. We should always consider data as an asset. And there are other frameworks like expected value framework. When we are trying to build a solution for a business problem, we can utilize the expected value framework for that. And we can try to identify the patterns. As we discussed, generalization is one of the key techniques. And we should also be careful about overfitting, that we are not trying to fit to the current data set what we have. We should be always generalizing so that the model will work for the unseen data. And then the EDA, right, exploratory data analysis, what we call, is actually a different ball game, and it should be really having a different level of effort and different skills. Then this is what the expected value framework, which also talks about decomposing the business problem into sub problems, and decomposing data elements which are in-house and also which are acquired from different sources, and then how to put these pieces together. So it all talks about the probabilities and how to apply this conditional probability and combined probability, so that we can get we can stitch the pieces together to get a final solution from all the decomposed small parts. Yeah, these are some of the key terminologies from the knowledge, like attributes. And when we talk about attributes, it's all about which attributes are important, right? How we can correlate with the other attributes, or which is important in terms of extraction of information, and what model is fitting to my data set, whether I'm really overcomplicating my model, or is it too simple. these are some of the terminologies which business teams should understand, and the technical team should be focusing on whenever they're trying to build solutions. And this, I think we discussed, right? So right from the problem definition to hypothesis and metrics, then collect the data, visualize, analyze, synthesize, and then communicate. So this is a generic 10 steps. And some of the detailed kind of analysis we can do on data set, like when we talk about univariate, we can have these metrics like mean, median, mode, and a range or quartiles, and how data is spread. We can understand the standard deviation or the variance in data. And on the multivariate side, there are different techniques like factor analysis or ANOVA and discriminant analysis. So these are some of the techniques which we can use to analyze the data and understand how data is spread or how data is there in the organization. And coming to some of the algorithms or some of the techniques, try to list down top or maybe popular things like classification. When we talk about different categories and we want to see how data is falling into one or more classes, so these are the classification techniques which help us. And scoring is also similar to classification, but here we don't talk about whether my data is falling into one class or other class, but we'll see how much probability or what is the ratio of particular label for this data set. So then regression, we talk about continuous variable. We want to predict the value of a continuous variable in the future. So that's where regression techniques will help us. And similarity matching. So we normally see the similarity matching based on product recommendations. If we want to recommend one product to other or one product to other customer, so we use the similarity matching techniques, and then we can try to use them in recommendations. And similarly, clustering, it will try to see the natural groups in the data set. And we talk about co-occurrence. So this is also called as market basket analysis. And the profiling. So profiling techniques help us to understand the behavior of particular data or individual. Link prediction normally used in the social networks or graph analytics, where we want to try to predict the links. Data reduction is again an internal process where a larger data set is converted into a smaller data set. And causal modeling, we use causal modeling to understand how the actions are influencing the others. And some of the best practices, I think I'm skipping this because we already discussed most of them already. And yeah, some of the issues in data mining, yeah, there are some of the issues which I can highlight, like uncertainty in data sets when we're trying to handle them, and when we should deal with missing values in data sets, and deal with the noisy data, and lack of domain knowledge, or complexity of the underlying data, and efficiency of particular algorithm in our particular situation. So these are some of the issues which normally we try to encounter when we try to extract the information or try to mine the data and extract insights. Then data mining applications. Yeah, I think try to list down across different businesses. So in the finance domain, we want to predict the customer loyalty or customer behavior for a new services or products. In the healthcare, we can try to apply for go-to-market strategies for with rapid access, and relation between disease and effectiveness or treatments. Telecommunication, we can also try to predict customer behavior or churn of customer. In retail, I think these are most yeah, frequently used, like recency frequency on monetary groups, and try to understand RFM part of the customers. E-commerce, definitely a lot of data mining is used here to upsell and cross-sell their products and recommend the products to the other customers. And marketing and sales can definitely leverage to understand the patterns inside the historical data, and then what combinations which are going together. And some of the benefits when businesses use these techniques, definitely improve data management efficiency and better customer experiences, and definitely all will result into increased revenue and growth and profitable business. and also improved analytic efficiency. So whatever we are analyzing, they are accurate and correct. So then we move on to strategies which can be applied, or best practices, like the data warehouse. So because whatever the techniques or whatever the algorithms we apply, we should have a proper data warehouse in order. And without that, yeah, none of them will be relevant, and none of them will be working. So definitely data warehouse should be in order, and it should suffice all the requirements which are stated by the AI engineering teams. So the team should work together, and then the data science or AI team should provide the requirements in terms of data warehouse, which were built in the particular business environment. And pipeline of use cases. So as we also discussed, so none of the business problem comes with predefined mapping with any of the algorithm or any of the technological solution. So we should try to break down or drill down that and try to create a chain of use cases or pipeline of use cases, and how to connect them internally, and see which one will feed which one, and ultimately find an end-to-end solution. So then last, engineering teams. Definitely, it's a teamwork. Whenever we want to build any AI-based solution, it's definitely a team of data scientists and business analysts, developers, operation team, and project managers, and others. So all the cross-functional teams should be involved uh, in development of these kind of solutions, because what happens if we involve them in the later stage? So we might miss out something. So definitely, it's always recommended to have all the cross-functional teams in this kind of development environment. So with that, yeah, I think I'm at the end of my presentation. So now, yeah, we are open for questions.
All right, thank you very much. And thank you all for joining us here today. I have a few questions for you, Pradeep. The first one is, how do you justify data quality or governance in terms of costs?
Uh, yeah, so definitely, I think that's an important point, because data quality is very much important in any organization. Without without a quality data, whatever analytics we build, that's all useless. So we should be trying to take a balanced decision and then see what is the cost benefit. So if we are really taking a big business decision, and if the underlying data is very poor quality, then that is having a big impact. So definitely we should see where is that data is used, and what analytics we are building on top of that, and what kind of business decisions we are taking on it.
Okay. And the next question is a little bit complex, and this might require an offline conversation as well. But the question is, can you share an example of profiling the data elements and share the final data model?
Yeah, so that's actually a good question, because profiling data elements is like, we should understand the data, right? So data in terms of the attributes what we have, and in terms of what are different columns, and how the data is related to each other. So data profiling, yeah, it really requires and thorough study of the particular project, and what are the business use case we have.
Okay,
I think I answered the question
great.
partly.
And then is there any chance for SMEs to use this solution, so small and medium-sized enterprises?
Yeah, absolutely, definitely, because these are all the best practices which are followed across the different businesses, right? And so it's all about the thought process. And what I can say is, it's not tied up with any kind of domain. It's because we talk about CRISP, right? It's a cross industry standard, and it's not again tied up with any small, medium, or big business. So any business can follow these models, and develop the better data management practices, so which leads into better analytics and better decisions.
Great. And the next question is how to overcome leakage while preparing your data.
Yeah, so leakage we discussed about data leakage because so I can take a quick example here. So when we are trying to build a model based on maybe 10 different variables, and I already have 10 variables because I am working on the historical data. But when we go and try to deploy that model in production, the 10th variable might not be available when this particular model is kicked in. So at that time, what happens? Definitely the model will underperform or the model will fail, and the predictions or whatever the output is not as per the standard. So we should be very careful. That's why the business understanding and data understanding is very important before applying or before developing any of these modeling techniques. So that is the one of the way. So there is no silver bullet which I can say that this will solve this. But yeah, one of the ways try to understand data and the dependencies and how it is coming in the real time, what is available, what is not available, and then proceed.
Okay, great. Let's see. Our next question is, how do you select informative attributes?
Um, okay. So definitely there are multiple techniques which we can apply, like correlation, or we can see the dependencies between multiple variables, and we can try to plot their dependencies and visualize them, or we can try to put them in some of the algorithms and see what is the significance level of that particular variable. So yeah, there are multiple ways. Again, it is specific to the business and specific to the use case, where we need to understand what is the importance of this variable in this business in terms of both the model performance, technicalities, and also the business.
Okay, great. Let's see. The next question is how to fix bad data quality.
Um, so bad data quality is kind of uh, it's a problem where the people mindset should be changed, because most of the times when people try to process the data or try to convert the data, and they try to migrate from one system to the other system, there might be some errors which might happen in the system. Or when we capture the data, the systems are not performing well or not capturing with enough precision. So there are some of the aspects in terms of people, and some aspects in terms of systems. So it should be tackled from both ends.
Okay, thank you. And this is an interesting question. If data is an asset, how can this asset be included into accounting systems and value assigned?
Yeah, so definitely data is an asset only, but again, there is a, kind of condition, like if we could able to extract insights out of that and use that to take better decisions for business, only then it can be an asset. And yeah, so business teams can definitely consider only when we are able to leverage it and then understand and utilize it. Otherwise, having tons of data and without using it, so it might not be a real asset, because we discussed about the timeliness as well. So what is important information or important data today that might not be relevant tomorrow because of changing regulations or changing dynamics in the market or competition, something else might come up. So if you're not utilizing it, yeah, it cannot be considered as an asset, but if we are utilizing it, yes.
All right, thank you. Well, thank you all for joining us. That is the end of our time here this morning. And thank you so much, Pradeep, for sharing your insights with us about how data can be turned into an enterprise asset. If you have any other questions, feel free to contact us. We will also be sending out the replay as soon as it is available. Thank you very much for your time, everyone, and have a wonderful day.